Hello friends, and welcome to the another lecture on air pollution and solid waste management. And today we will see the meteorological parameters such as wind, humidity, temperature, solar radiation, and all these parameters we will see and its effects. Okay, and even we will cover the atmospheric stability. And before starting, I would like to introduce myself. I am Amey Khedikar, working in the Department of Civil Engineering at Tulsiramji, Gaikwad-Patil College of Engineering and Technology, Nagpur. So, we will begin up with the meteorological parameters, and basically what are the meteorological parameters we will see first, such as wind speed and its direction, then temperature, then humidity, then rainfall and solar radiation. So, basically the air movements influence the fate of air pollutant. So, any study of air pollution should include a study of the local weather patterns, meteorology, that means meteorology. On the other hand, when strong turbulent wind blow, pollutant disperse quickly, resulting in lower pollution concentrations. So, meteorological factors such as wind speed and its direction, then temperature, humidity, rainfall, solar radiation, air movement, okay, and all these things. So, in the factors we can start with the air movement influence the fate of air pollutants. So, any study of the air pollution should include the study of local weather pattern, that is meteorology. If the air is calm and pollution cannot disperse, then the concentration of this pollutant will build up. On the other hand, when strong turbulent wind blows, pollutant disperse quickly, resulting in lower pollution concentrations. So, in order to have help the meteorological data which helps to identify the source of pollutants, predict air pollution events such as inversions and high pollutant concentration, days stimulate and predict air quality using the computer models. So, the meteorological parameters which helps with the help of computer models, okay, then which they stimulates and predict air quality also. When studying air quality, it is important to measure the following factors, as they can help us understand the chemical reaction that occur in the temperature. Okay? And we have now seen earlier twice that the parameters like wind direction, the temperature, the humidity, the rainfall, then solar radiation, these are help us to understand chemical reaction that occurs in the atmosphere. Now, we will see one by one the wind speed and direction. See, when high pollution concentration occurs at monitoring station, wind data records can determine the general direction and area of the emissions. Identifying the sources means planning to reduce the impacts on air quality can take place. An instrument called an anemometer measures wind speed at our monitoring stations. The type of anemometer that we are using is sonic anemometer. An instrument called anemometer measures wind speed. And in our monitoring system, it is a type of anemometer we use which is of sonic anemometer. A sonic anemometer operates on the principle that the speed of wind affects the time it takes for sound to travel from one point to another. Sound traveling with the wind will take less time than sound traveling into the wind. By measuring sound wave speed in two different directions at the same time, sonic anemometers can measure both wind speed and direction. Okay. And then temperature, the second meteorological parameter is temperature. See, measuring temperature supports air quality assessment. By measuring the temperature, we can assess the air quality modeling and forecasting activities, whether the rain is expected or not. Even temperature and sunlight, solar radiations play an important role in the chemical reaction that occur in the atmosphere to form photochemical smog from the other pollutants. Favorable conditions can lead to increased concentration of smoke. The most common ways of measuring temperature is to use material with the resistance that changes with temperature, such as platinum wires. Sensor measures these changes and converts into a temperature reading. So, temperature is one of the most important parameters in the meteorological factors which used to assess the air quality and the forecasting activities. It also favorables conditions to lead increased concentrations of the smoke. The most common ways of measuring temperature is to use material with the resistance that changes with the temperature, okay, such as platinum wire. Humidity, okay. Like temperature and solar radiations, water vapor plays an important role in many thermal and photochemical reactions in the atmosphere. As water molecules are small and highly polar, they can bind strongly to many substances. It attached to particular suspended in the air, they can significantly increase the amount of light particles suspended in the air. They can significantly increase the amount of light scattered by particles by measuring the visibility. If the water molecules attach to corrosive gases such as sulfur dioxide, the gas will dissolve in the water and form an acid solution that can damage health and property too. It is very important to consider this factor. Water vapor contents of air is reported as a percentage of saturation vapor pressure of water at a given temperature. This is the relative humidity. The amount of water vapor in the atmosphere is highly. Okay. So, these are the things, if the amount of water vapor is highly variable, and it depends upon the geographical location, how close water bodies are, wind direction, air temperature, then relatively humidity is generally higher during the summer, with temperature and rainfall are of their highest. Measuring humidity uses the adsorption process and properties of the polymer film. The film either absorbs or loses water vapor. As the relative humidity of the ambient air changes, a sensor measures these changes and converts them into humidity reading. Okay. Now, rainfall. It is one of the major and important meteorological factors. Rain has a scavenging effects when it washes particulate matter out of atmosphere and dissolves gases pollutants. Removing particles improves visibility. Where there is frequent high rainfall, air quality generally better. Where there is high rainfall means there is lot of forestation, and rainfall is less in case of deforestation. So, it can be assumed that where there is a frequent high rainfall, the air quality is generally better. Okay. If the rain dissolves gases pollutants such as sulfur dioxide, it can form acid rain resulting in a potential damage to material or vegetation. A common method to measure rainfall is to use tipping bucket rain gauges. The gauge registers rainfall by counting a small amount of rain collected. When the rain falls into funnels, it turns into container, the tipping bucket that we call, which divided into two equal compartments by partition. The design of tipping bucket makes one compartment tilt downward and rest against a stop where it is empty, positioning the other compartment under the funnel ready to receive the rainwater. You can see here. Okay. Now, you can see the motion also, the tipping bucket rain gauge. You can see the water is allowed to flow from the top side where the set amount of rain has drained. From the funnel into the upper component, the bucket ties the opposite way so that the compartment containing the rain comes to rest against the stop on the opposite side. The collected water then empties out and the other compartment starts to fill. You can see this can be understood with the help of the motion you can see on the right side of the slide in the instrument. The instrument calculates the quantity and intensity of rainfall using with the area of the funnel and the number of rate of the bucket movements. Okay. A set of amount of rain has drained from the funnel into the upper compartment. The bucket tilts the opposite way so that the compartment containing the rain comes to rest against the stop on the opposite side. You can see in the image. Now, the next meteorological parameter is solar radiation. It is important to monitor solar radiation for use in modeling photochemical smoke events, as the intensity of sunlight has an important influence on the rate of the chemical reaction that produces the smoke. The cloudiness of the sky, time of delay and geographical location all affect sunlight intensity. Okay. An instrument called pyranometer measures solar radiation from output of the type of silicon cell sensor. So, it is made of silicon cell sensor and a pyranometer measures the solar radiation. So, it is also important to monitor the solar radiation for use of modeling photochemical smoke events. Okay. The cloudiness of the sky, time and day and geographic location affect the sunlight intensity. Okay. Now, after the meteorological parameters such as wind direction, then solar radiation, then humidity, then temperature, now we will see the atmospheric stability. Now, what do you mean by atmospheric stability? The theme now completely is different of both presentation and both lecture. Now, after the importance of that we have seen of the meteorological parameters, now we will see the atmospheric stability. So, stability is a property to maintain the equilibrium state. Okay, in better words we can say the ecosystem of the environment. It is the property to maintain the ecosystem of the nature. Ability of the atmosphere to retain its position is said as atmospheric stability. Atmospheric stability can be clearly defined by the simple term that ability of atmosphere to retain its position or to maintain the ecosystem or to maintain the equilibrium state. That is all about the atmospheric stability. Okay. Now, why we have come across some disturbance in atmosphere? Because of the pollution, because of the pollutant, because of the pollution, we are coming across a term called disturbance in the atmosphere. So, due to application of various forces, a distribution is caused in the atmosphere. Okay. Now, atmospheric condition, there are three conditions: neutral, stable and unstable. Okay, so there are three conditions of atmosphere. First one is the neutral, second is the stable and third one is the unstable. So, neutral means it may remain at new altitude, that is neutral condition. And stable condition means it may return to original altitude, that is stable condition. And unstable means it may continue upward the movement which cannot come to its original altitude, that is the unstable. So, there are three phases of the atmospheric: stable, unstable and neutral. Okay. Now, displaced air may remain at new altitude. Okay. Now, you can say that the neutral kind of situation is there, where the vertical movement of the air in the atmosphere, you can see that neutral, and the displaced air may remain in the new altitude. Okay. So, that displaced air may return to the original altitude. Okay. So, see that the temperature is showing the two conditions, one is stable at the night and one is unstable during the day. So, at the night the vertical movement of the air in the atmosphere which is stable, but in the morning you can say that the vertical movement of the air is the unstable, it can come down. Okay. So, that is the disturbance. Okay. Then dispersed air may continue upward the movement, that is the example of unstable case, where the vertical movement of the air in the atmosphere, that is the unstable case. Okay. Vertical movement in the unstable case, you can say unstable. So, it is the third state, unstable. This is the stable case and this is the neutral case. Okay. So, where the vertical movement of the air which is neutral. Okay. Now, this is going downwards, so it is unstable. Okay. And this is the that is the stable and that is the unstable. Okay. So, first image stands for neutral, second for stable, third for the unstable. Okay. Now, heating and cooling on surfaces. Okay. So, you can see stable at night, unstable during the day. So, heating and cooling at the earth surface, that is the stable at night, you can see that, but it is unstable during the day. This is also a considerable process of heating and cooling on surface. Okay. Now, stability phenomena. So, heating from below promotes the instability and cooling from below promotes the stability. With this image can clearly justify that the cooling from the below which promotes the stability and heating from below promotes the instability in the atmosphere. So, stability of the atmosphere has two phenomena, that heating from the below provides instability and cooling from below provides the stability. Okay. Then the parameters of displaced volume, such as mainly there are parameters such as temperature, pressure, density. So, parameters which vary with respect to the altitude are temperature, pressure and density. Yes, these are vary with the respect to altitude. Temperature may vary, pressure may vary and density may vary with the respect to the altitude. All atmospheric condition relates to an density of the atmosphere at corresponding altitudes. Okay. Then the temperature, pressure, these are varies. Okay. And all atmospheric condition relates to the density of the atmosphere at corresponding altitudes. Okay. Now, you can see here. See the temperature distribution of vertically moving air. Okay. So, in the left hand side you can see the temperature distribution of vertically moving air. Okay. And the compression and the waves. Okay. So, say first image stands for expands and cools and second stands for compresses and warms. Okay. So in that case you can see the temperature distribution of vertically moving air, it is in case of expands and cooling, it is going upwards, the rising air is going upwards, and in case of the compress and warms, the rising air is moving towards downwards. Okay, so these kind of things. So in case of expands and cools, the rising air is going upwards around 9,000 feet. Okay, and in case of the compress and warms, the rising air is falling down to something around 1,000 feet. Okay, so that is the difference of temperature distribution of vertically moving air in case of expands and cools and compress and warms. Okay, so it's moving upwards and it's moving downward respectively. Now lapse rate. Okay, so lapse rate is defined at rate at which air temperature changes with height. So lapse rate is defined as the rate at which temperature changes with height. Actual lapse rate in temperature is approximately -6 to -7 degrees Celsius per kilometer in the troposphere. Troposphere is one of the layer in the atmosphere, so it is defined as the rate at which the temperature changes with the height, and actual lapse rate in the atmosphere is approximately 6 to 7 degrees Celsius per kilometer in the troposphere. Now we will see the importance of atmospheric stability for flying bodies. Okay, stable atmosphere provides an equilibrium state of motion to flying objects. An unstable atmospheric condition will cause disturbed flight, which may leads to flying objects to an accident. Before every flight, atmospheric stability is analyzed in order to have a safe journey. So as far as flying bodies, jets, aeroplane flights and domestic flight, international flights are concerned, the stable atmosphere provides an equilibrium state. The proper ecosystem has to be maintained, which is very essential for the flying aeroplanes. An unstable atmospheric condition will cause the disturbance. This signal may not get, there will be chances of loss of signals, the radar system will not work and may leads to flying objects and accident. And before every flight, even after it's a routine practice that before every flight atmosphere stability, it is analyzed in order to have a safe journey. Okay. Now what is Plume in the air pollution? That is also one topic which is included here. So what is Plume in the air pollution? Air pollution emission Plume, it's a flow of pollutant in the form of vapor or smoke released into the air. So it is in the form of vapor or smoke which is released in the atmosphere into the air. A Plume may have a higher density than air because it has a higher molecular weight than the air. For example, plume of carbon dioxide, it's have a higher molecular weight than the air. Then behavior of Plume depends upon the adiabatic lapse rate, height of stack chimneys, experimental lapse rate, okay, environmental lapse rate. So the behavior of plumes depend upon the adiabatic rates, the height of the stacks, chimneys. Chimneys are the tall structure which is used to remove the smoke, waste smoke and hazardous gases coming out of the industry, which the height defines that the smoke should release at a higher altitudes, so that it cannot cause to the societies nearby, surrounding nearby. Okay, you can see here the dispersion of the emitted gases from the sources of their production is known as plume, and this source is known as stack. So chimneys should have tall enough so that it can chimneys are tall enough so that it can release the smoke at high altitudes. You can see there is no chimney, so the smoke is released at the ground level, and it is known as the plume, and the source is known as the stack. Okay. Now there are different types of plume classified in the ELR and ALR. So the different diffusion or dispersion of the pollution into the atmosphere is governed by the environmental lapse rate as well as the adiabatic lapse rate. Okay. So ELR stands for environmental lapse rate and ALR stands for the adiabatic lapse rate, that is atmospheric temperature. Okay. So the diffusion or dispersion of the pollutants into the atmosphere is governed by the environmental lapse rate as well as adiabatic lapse rate, that is example. So you can see here the looping, the coning, the fanning and the lofting, where the looping is which is very dangerous, so that the flume is coming down to the surface where the coning, the best part is the fanning and the lofting. So it is supposed to be done. Okay. And then looping flume is the wavy character and occurs in the super adiabatic environment, in which the environmental lapse rate is greater than the adiabatic lapse rate, which produces highly unstable atmosphere because of rapid mixing. In an unstable atmosphere, rapid air movements takes place vertically both upward and downwards, and the flume becomes a looping flume. Okay, you can see in the image it is clearly mentioned that. Moreover, as a result of this, high concentration of the pollutants may occur near to the ground, which is very harmful, and to disperse these pollutants is advised to design a high stack where atmosphere is generally super adiabatic. Okay. So looping flume is where the it is touching to the ground, and which is very harmful. The images are showing the rising of the thermal, where the connective mixed layer, then subsidence. So it is touching to the ground, which is harmful. Then the neutral flume occurs in the neutral atmosphere condition, where the environmental lapse rate is equals to the adiabatic lapse rate. Such type of the flume rises vertically in an upward direction. The upward lifting of the flume will continue till it reaches a height where density and temperature of surrounding airs are equal to it. So you can see in the images where the environmental lapse rate, which is equal to the adiabatic lapse rate, and the upward lifting of the flume will continue till it reaches to the height. So it will not move in a horizontal direction, it will only move to the vertical direction where the density and temperature of surrounding air are equal to it. Okay. So I hope you have understand these things, and we have seen the atmospheric stability, the lapse rate, then the environmental lapse rate, adiabatic lapse rate, then the meteorological parameters, then flume. So all these things we have seen, and I hope you have understood this. So it is one of the important parameters as far as the air pollution control is concerned, the factors affecting it, and a factor which is having most impact on it. So I hope you understand. We will again meet with the next lecture. So thank you very much.